Hello everyone, this is Rendong Luo from Cornell. Today I would like to present our paper, ShadowDraw from Any Object to Shadow-Drawing Compositional Art. This is a collaboration with Noah Slavy and Wei Ma. And now let's look at some cool art. To begin with, let's look at this image. What do you think it is? There are multiple possibilities. It might be a cat or a dog. But today, if we put a 3D object on the top and cast a shadow, it suddenly becomes a rabbit. And that is exactly the core idea of our work. Our goal is to take any ordinary object as simple as this household scrub brush into the striking shadow art as I have just showed. And to achieve this, our system needs to determine two things. The first is the object pose and lighting position, and the second is a partial sketch. And then we can place the object and light to get the shadow, print out the sketch, combine them, and get this very cool Batman. This concept is not new, and it is proposed by the Belgian artist Vincent Bell. And here's an example showing how the artist incorporated a chocolate bar with sketches and forming this playful accordionist. But creating this art is not simple. Even for professional artists, it requires iterative trial and error. And with our system, we want to make everyone an artist. Although I have very little artistic talent, I can follow our system, trace the generated sketch, place the object at the predicted position, turn on the flashlight, and arrive at the desired result. So now let's dive into the framework that makes all of this happen. Our framework consists of three components. In the first component, we select positions to place the object in the light. In the second component, we decide what to draw and how to draw. In the last component, we do a quality control where we filter out the bad results and surface the good ones. And now let's go through these components one by one. So here, when place the object in the light, the big question is, what makes the shadow exciting to look at? Intuitively, we want a shadow that feels irregular, expressive, and visually rich. And to measure that, we use fractal dimension, which is a statistical way to capture the shape's complexity, and higher means more complex. And the best part is, this metric is differentiable, so we can actually optimize the object pose and lighting to hunt for these very compelling shadows. And then we need to figure out what to draw. This is even hard for trained artists, so we turn to modern VLMs to help. And in practice, we provide VLMs with detailed instructions and in-context examples, and let them imagine what we can draw based on it. Next, we need to decide how to draw. For this, one straightforward idea is directly use an off-the-shelf image generator. However, even today's strongest text-to-image models still don't really understand the very specific idea of shadow art and fail to make use of the shadow properly. So rather than asking the model to generate the whole artwork end-to-end, our key idea is to reframe the problem as sketch completion. In practice, we extract the contour of the shadow and consider it as an incomplete sketch, and let the model to generate the complete sketch. Finally, we subtract the shadow contour from the complete sketch to obtain the partial sketch we want. Finally, we discuss our quality control module. Let's use this alphabet H as an example, and suppose we already have these two candidate results with the shadow contour highlight. In first step, we verify the shadow ground coherence by using the VLM as a judge and ask it if the shadow contour plays a critical role in the composition. And in this case, the left result would receive yes, and the right result would receive no, and thus would be discarded. In the second component, we assess the contribution of the shadow. Specifically, we compute the difference between the complete sketch and the partial sketch on a set of text-image alignment metrics. And if the difference is higher, it means the shadow contributes more to the composition, and thus that result will be preferred. And finally, for the alphabet H, we arrive at this result as the best result. And here's a real-world deployment example where we use alphabet C to create a woman with a hat. And here's another example where we use alphabet B to create this very cool basketball attendee. And here's another example where we use this red mug to create this very cute ghost. Our framework naturally extends to multiple objects, We can compose them and form all different kinds of characters, including this bird, this dog, and this horse. That's all for my presentation, and welcome to our poster to see real-world deployment results.